Hi. So today what we're going to talk about is the changes that we made in this last week. We focused on our program, our trajectory program that we're using for simulation, that's basically going to be what's piloting our craft to the moon. And one of the things that we worked on was before our program, the trajectory program, used a local file, with information on the position of the sun, the Earth, our craft, and now we've actually ported it to an XML file that we could access through a server, and all our ground stations are going to be using. So if you pan in here, so this is basically the file here, and here's the engines that we're going to be using in the future, actually here, not at the moment. And this is essentially when our firing is going to happen and at what angles, and then here's our optimization, and this will actually, this information is for optimizing the proper angle of fire or proper time, but that's for the future. Right now what we're using, this XML file is actually for the ground station, and so we want to calculate the angle of the antennas that we're using our ground station to communicate with our craft. So the second XML file, if you take a look at it, I'm just going to refresh it. So it's our batch. Oops. This is here. One second. So this is all the data. That's the new data, refreshing data of our craft and of satellites. And so if we refresh this, we will see this is constantly calculating, and our ground stations will be able to pull from this XML file. And if we go back to our page here, so this is what you saw last week. This is very similar, right? So if we zoom in, this is actually the GPS satellites right here. So if we zoom in, the changes that we made since last week is before, remember when it was supposed to be sunny, the sun was on the wrong side. But if you take a look at what these lines are here, this is actually the horizontal angles here. This represents the ground station Hawaii. We got Vancouver up top, okay, so if you take a look, we've added some of these lines, and you're probably going, what does all this mean? So this is our craft right here, right, and it's flying. It's dynamically refreshing, and you see these planes, these guys, these lines, these 4 lines, and if you take a look at them, what they are is they're actually the horizontal with the Earth, and this is perpendicular to the Earth's surface. So we got, and then this line is either pointing south, or there up top we have representing north. So if you take a look, we actually don't have our craft in any of the planes of our ground station. So it's kind of we can't either communicate to it or whatever. So once our craft is in position of one of these ground stations, right, what will happen is that the ground station antenna will change to the area of the craft to communicate with it. And so, the data where the ground station will change, with the data that the ground station is taking from, is our XML file that consistently gets refreshed as the craft goes on and on. And the whole purpose of this last week was just to have this ability here, is if you remember 2 or 3 weeks ago, we showed you this interface, and this was to position to show the angles of each ground station of the antenna. And so what we've done is we want to set that ground station to operate autonomously based on the XML data, and now it will fire and turn its angle towards the craft autonomously now. So another thing that we're working on is, if you take a look, this is our SolidWorks drawing of the rover, and we're going to be using it for a ground station. And the actual rover, we want to use the same technology. If you take a look, what we have here is this is a quick mock-up of what's going on in our wheel, and this is where we're going to have our antenna that's going to be rotating right in between here. So if you take a look, we have lots of clearance here, but once it's moved in here, obviously the clearance is gone. So we're going to be redoing this part, and so yeah, this is thank you for tuning in, and we'll see you next week.